So this is lesson 2 on stoichiometry. So stoichiometry is I think I'll mute Mihir for now because there's a bit of a background noise from you. Just try not to touch your microphone as much as possible. So stoichiometry is a subject of quantitative chemistry. So it is an area where we deal with numbers and ratios and things like that. And this lays the foundation of chemistry. So last time we learned, just as we call 1 dozen, that's a collective unit for 12 eggs. There's a concept of 1 mole. And 1 mole is a very big number, 6.022 times by 10 to the power of 23. This could be atoms. So it's just, if you count up to this much, that's called 1 mole. Atoms, or this could be molecules, could be particles. Now, and the number of moles is given by simply the number divided by this Avogadro's number. So this is known as Avogadro's number. Avogadro's number, and the symbol for that is Na. So for example, if I give you number of eggs divided by 12, that gives you number of dozens, right? So if I have 48 eggs, divide that by 12, then I get 4 dozens, right? So if I have, let's say, 3 times 10 to the power of 25 atoms, then how many moles of atoms do I have? Simply divide that by 6.022 times by 10 to the power of 23. So let's have a look at that. So that's 3 times by 10 to the power of 25. And then you divide that by 6.022 times by 10 to the power of 23. Then you get 40, about 50. So this number here is the same as 50 moles. So 50 moles, as I said before, mole is a collective unit. So the reason why we use this notation, this unit here, is because when we deal with chemistry, even like a single drop of water contains gazillions of particles, right? Gazillions of molecules, lots and lots of molecules. So it's not really, if I tell you, like there are 3 times by 10 to the power of 25, like water molecules, this doesn't really come to our mind. We can't really feel how much that is, right? So that's why we translate that into some number that we can perceive, and we say 50 moles, okay? Now, and there's also this concept in chemistry called molar mass. So if you look at your periodic table, maybe you guys all have this on your science book. Mihir, have you got a periodic table on your science book?
Yeah, I do.
That's great. So if you look at your periodic table, and Leo, you do as well?
Yeah.
Great. I'm going to copy this one. You'll notice that these guys have little numbers there, right? So there's a 3, 6.94. There's a 2, 4.0026. So for helium is number 2, that means it's got 2 protons. Oxygen is number 8, so it's got 8 protons, 9 protons, 10 protons, etc. Okay. But you can see that this number here is roughly double of this number, isn't it? That's 2 times that. That's about 2 times that. Oh, this is actually an exception. It's 19 there. This is about 20 there. This is about 30. That's 40. So it's about twice, you know. But as you move on, it becomes more than double. 54 times by, 2 is 108. So this is 131. So what are these numbers in decimal places? So these are known as relative atomic mass. So we'll talk more about that. And what that means is, it's actually what it means, but if I have 1 mole of helium, that means 6.022 times about 10 to the power of 23. So why is this number special? If I have that many atoms of helium, this will weigh exactly 4.0026 grams. You guys know what gram is, right?
Yeah.
1,000 gram is 1 kilogram. You guys all know what 1 kilogram feels like.
Yeah.
And if I have 1 mole of 1 mole, so that many of oxygen, okay? Let's say O2. In this case, it's not atoms, it must be molecules. Because when you have a helium atom just by itself, that's an atom. But when you have like oxygen atom with another oxygen atom together, they exist as O2. They are bonded together. I'll tell you the reason why later. So that's no longer an atom. So that's an atom, but if more than 2 atoms are bonded together, we call that what? Leo?
A molecule.
That's right. So this is an atom here. That's a molecule here. So if I have that many molecules of O2, so that means oxygen, that's one molecule, that's 2 molecules, 3 molecules, etc. How much would it weigh? Can you guys figure it out and type your answer on the group chat? You can do private message to me if you want. How much would it weigh? How many grams? Mihir? Okay. The answer is about 32, isn't it? Because that's 16 there. But you've got 2 of them, so it's going to be about 32 grams. Okay. So if I have 1 mole of water, that means I need to have, let's think about that, this many molecules of water. How many grams would it weigh? I want you to think about that. So there's a hydrogen there. I'm going to copy and paste that. So that's hydrogen there. I want you guys to try this. You can type your answer on the group chat. Just give it a go, even if you're not sure. All right, I think the answer is 18 because you got 16. So that's 16. You got 2 hydrogen, right? So that's 2 hydrogen. So it is about 1 plus 1 plus 16. 1 plus 1 plus 16. So that will weigh 18 grams. So this concept here is known as molar mass. Molar mass, and the symbol for that is MR. Molar mass. And the unit for this is certain grams per mole. Because if you have 1 mole, you have 18 grams. So for the molar mass for water is 18 grams per mole. Okay, so I'll give you some exercise here. What is the molar mass of N2? What is the molar mass of H2SO4? Try that. So what's the molar mass of N2? You can type your answer. What's the molar mass of H2SO4? That's known as sulfuric acid. You can try molar mass of HCl. You can try that. Take your time. So everything that you need is here. N is right over here, nitrogen. O, there's an S there. There's a Cl there. There's a hydrogen there. Okay. Mihar, got any answer for any of those here?
Yeah, I just figured out the first one. I still have to do the other two.
Okay. So how much was the first one?
So would it be 28.014?
Right. 28. And the unit for that, you have to put grams per mole, okay? That's the unit. This one here. Shamshir, have you got, Leo, have you got this one here? HCl? Have we got an answer
Yeah.
for that? Very good. So Mihar also got 98 for this. That's about 98 grams per mole. HCl. That's right. 36.5, right?
Yep.
And that's all grams per mole. So that's the concept of molar mass. Now, if we just go back to this formula, number of moles is equal to number divided by Avogadro's number. There is also another formula for the number of moles, and that is mass divided by molar mass. This is a lot more used, much more used formula than this one here. So I'll give you a small quiz. Okay. Example rather than a quiz. If you have 70 grams of oxygen gas, how many moles are there and therefore how many molecules, and therefore how many atoms. So let's work it out together, okay? So we know that in 1 mole, the molar mass of O2 was how much, Liam?
Wait, sorry, what was that?
What was the molar mass of oxygen 2? There are 2 oxygens. We just scroll
32.
down a little bit.
32 was that?
Right? Because 16 plus 16, true?
Yeah, 32.
So the molar mass of oxygen is 32 grams per mole. That means in 1 mole, you're going to have 32 grams. If you have 2 moles, you're going to have 64 grams. If you have 3 moles, you're going to have 96 grams, right?
Yeah.
If you have 70 grams,
Oh, okay.
how many moles? That's the question here. You can try that now using this formula here. Just figure out this one first. Okay. Just waiting for answer from me here as well. Okay. So the answer is somewhere between 2 and 3, isn't it? Because 64 grams is 2 moles. Because 1 mole is 32, 2 mole is 64, 3 mole must weigh 96. So 70 grams is somewhere between 2 and 3. And the formula is just divide the mass by molar mass. So that gives you, we just use the calculator here, 70 divided by 32. That means within 70, you can fit about 2.1875 moles. 2.1875 moles. Now, let's talk about how many molecules there are. Okay, so we know that in 1 mole, there are 6.022 times about 10 to the power of 23. So if you have 2.2 moles, that'll be twice this one. So that'll be 1.2044 times about 10 to the power of 24. Makes sense? So if I have 2.1875 mole, how many molecules, because that exists as molecules, right? The answer is, you just need to use that equation. Number is given by number of moles times by the Avogadro's number. That times by that is that, right? So that gives you, we have 2.1875 times that by 6.022 times about 10 to the power of 23. So simply timesing this by, if you times that by 2, you get this one, right? If you times that times that by that, then you get this one. That's 1.317. 1.317 10 to the power of 24. Okay, so you have 1.317 molecules times by 10 to the power of 24. Now, in each molecule, there are 2 atoms. So if you have that many molecules, how many atoms are there? I'll give you some clue here, okay? If you already know the answer, you can answer the question. Now, in this diagram, how many molecules do I have? There are 5. How many atoms are there then?
10.
10. There are 5 molecules. And there are 10 atoms, right? So in this case, what's the answer to this one then? I've got 70 grams of oxygen. That counts as that many moles, because 1 mole is 32 grams. But that many moles is this many molecules. Because in 1 mole, there are 6.022 times by 10 to the power 23 molecules, right? So you get that many molecules. So the answer for this one is simply that times by 2. So you get 2.6, 34 times by 10 to the power 24 atoms. Okay. Now we're going to move on to the worksheet. So I think we covered up to question 5 last time. Is that right? H2N2. Yeah, so we're going to go through question 5 again, though, because it's a pretty fun question, you know? So I've got this one here. How many moles of H2N2 can be formed by the decomposition of 0.145 mole of ammonia NH3? Okay, so I've got NH3, and that looks like this. You've got N, H, H, H. Okay. Now, this can be decomposed into H2, which is like that, and N2, like that. That's what this is NH3, this is H2, and this is N2. But this cannot become that and that because I've got 3 hydrogen, that's 2 hydrogen, 1 oxygen, 2 oxygen there. So I can simply have another one of this. So I've got that. That means you need to have 2 here. You've got 2 NH3. 1 here, 1 here, right? And that's 6 hydrogens, so you can maybe have 1, 2, 3. That makes it 6, right? And that's 1 oxygen, so 1 oxygen, so that's all happy, right? So that means the balanced equation is 2NH3 becomes 3H2 and then 1 nitrogen, like that. Okay, so that's the balanced equation. So if 2 mole of ammonia is decomposed, that means it's breaking into these 2, you're going to get 3 mole. If I have 2 molecules, let's say 2 molecules, so that's literally 2 molecules there. This gives you 3 molecules of H2 and 1 molecule of N2. This can be changed to mole concept. So mole is definitely a larger number, much larger number than this one. 2 mole then gives you 3 mole. It works the same way with mole. All right? So mole is not the same thing as molecule. Don't get confused about that, okay? So mole is a collective unit. It's a counting number, whereas molecule is an object. So 1 mole. So this will be decomposed into that and that, okay? If you have 4 mole, this will give you, you guys can try this, how many mole and how many mole? I'll wait for your answer. If you have 4 of these, then how many mole of that and how many mole of that? Mihir? You can type your answer. Okay. Excellent. Very good, even though it's your first time. So 2, 3, 1. So 2, 3, 1. So if it's doubled, this one's doubled as well. This one's double, so 6 and 2. 6 mol, 2 mol. Okay. Now, now the question is, if you've got 0.145 mol of that, then how many of this will be produced and how many of this will be produced? That is the question. So I want you to think about that. So it's not an easy number here. I talked about this technique last week, so maybe Leo can easily figure this one out. But I'm going to give a little bit more time to Miher to see if she can figure it out. Okay. So instead of 4 mol, which gives you 6 mol and 2 mol, if you have 2 mol, 3 mol, 1 mol, if you have 0.145 mol, how many mol here and how many mol here? Yeah, so Leo's got an answer already, but Miher, don't look at Leo's answer. Just see if you can figure it out yourself as well. So I give you time until 6:40. Maybe 6:40 and then 30 seconds. So 30 more seconds to go. You can use calculator if you want. Any luck? Okay. So the idea is you can easily get all these numbers. So the ratio must be 2 to 3 to 1. Okay. So 0.145, you divide that by this number 2, and then times by 3. So which means you times it by 3 on 2, okay? So that's timesing it by 1.5, you know? So you see how this one is 1.5 times this one? So that gives you 0.2175. This one is 1 to 2. So that's just half of this one. So that gives you 0.145 times by, you divide that by 2 times by 1. Well, that's equal to just timesing it by 1/2. So that gives you 0.0725. So Mihar, if you go through the lesson 1 video, it'll make a lot more sense. Now, we're going to go through other questions now. So we're going to try question 6 here. So this is, a lot of students find this difficult to understand. We're going to go through this. So what's the total number of atoms in this molecule? This many mol of that molecule. Okay. So we have this gigantic molecule, which is made up of carbon, oxygen, carbon, 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 carbon in a hexagonal ring, and you have CH2 OH like that, and then there's a H, and then OH, H, OH, H, OH, H, H, OH, something like that. And if you count it all up, I think you have 6 carbon, one here, one here, 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 here. That's 6 carbons. Oxygen, 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 6 oxygens. And then carbon, hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's what this molecule looks like. So it's a big molecule. And this is in your blood, okay? We survive. We use glucose. That's a source of energy. So we use that we break it up to breathe, to exercise, or whatever activity you do, we use glucose for energy. So this is a source of energy. And it's also known as sugar, okay? Now, let's say I have 1 mole of this guy, 1 mole. Then if I times this one by 6.022 times by 10 to the power of 23, then I have 6.022 times by 10 to the power of 23 molecules. I've got 1 mole of molecules, which is that many molecules. That means that many of this thing. So we count that as 1. This whole thing is 1. Then, what do I have to do to get the number of atoms? I'll give you some clue. In 1 atom, there are 1 molecule. In 1 molecule, there are 24 atoms. Okay? If you found this one difficult, I'll give you another one. So let's say there is an egg, okay? So there's 1 egg. In 1 egg, there are 12 chicks, okay? There are 12 chicks in there. 24, let's say. You have 24 chicks in there, okay? Let's say I have 1 dozen. Then I have 12 eggs. Then I times it by what to get number of chicks? 2 or 24? Inside 1 egg, there are 24. So you have to times it by 24, right? So here I times by 12. Here I times by 24. That makes sense to you?
Yep.
But I can go another way. I can just times it by, I have 1 dozen eggs, but then I times it by 24. Then I have 24. In this case, it is a little bit difficult to understand. You have 24. By the way, let's figure this one. 12 times by 24. 12 times by 24. That's 288, right? You have 288 chicks. If I times 1 dozen eggs by 24, what I get is 24. And the unit for that might be a little bit confusing. Can you guys guess what this unit is? And of course, from here, you times it by 12. Then you get 288. Can you figure out what the unit for this one is? It is, because we times of 24, that means we're getting number of chicks, right? So we have 24 dozen chicks. So by multiplying by 24, we got out of the egg. So once we got out of the eggs, there are now chicks. And how many chicks are there? 24 dozen chicks. And how do you convert that into number of chicks? You times it by 12, because 1 dozen chick, so we have 1 dozen, another 1 dozen, another 1 dozen. So lots and lots of them. That's 24 of them. Each one of them contains 24. Actually, that's 24 dozen chicks, and inside each dozen there are 12 chicks. So it's a little bit confusing there, right? But the idea is get to number of chicks there, okay? Here as well, we got 1 mole. 1 mole equals to that many molecules. We have 1 mole of molecules. So we times it by the number of moles, then we get the number of molecules we get out of the mole. And then because inside of each molecule there are 24, you times it by 24, then you get the number of atoms. It's very similar to this picture here. But definitely a lot more difficult to understand because the numbers are not very nice. Times by 24. Then we get 1.445 10 to the power 25 atoms. Okay, that's the answer. Or we can go straight from here to just times by 24. So you have 1 mole of molecules. Can you figure out what this unit is going to be? So we get 24. Of course, 1 times by 24 is 24, right? So what do you think is the unit there?
Is it moles of atoms? Or...
That's right. That's very good. So we got out of the molecule. So because inside of each molecule, there are 24 atoms, right? So as soon as you times it by 24, we are coming out of the molecule. So there's no more molecules there, there's now atoms. So there are 24 moles of atoms. And then you, because we have 24 moles of atoms, but each mole is that much. So you times it by 6.022 times by 10 to the power 23. Then you get the number of atoms. Does that make sense to you? So you can go this way or this way. It doesn't really matter. So I'll show you the exact mechanism behind all this. So we know that 1 mole equals to 6.022 times by 10 to the power 23. We know that 1 molecule equals to 24 atoms. So 1 mole equals to this many molecules. So if I have 1 mole of molecules, I can times that by, because this is 1 mole equals that, so I can put 1 mole there. So 1 mole of molecules equals that many molecules. So 1 mole of molecules. So Mihir, if you watch the first video, this will make a lot more sense, okay? So I times it by that, and then 6.02. So I flipped this one, because that can be flipped, you know? So any ratio factor conversion can be flipped around. And then what happens is, if you, so I'm going from here to here by timesing by that, okay? Then of course you can see mole of molecules cancel out. And that's why you get molecules. You get 6.022, that many molecules. Then you have 6.022 times by 10 to the power 23 molecules. and then you times that by this one here. So one molecule should go down here. One molecule gives you 24 atoms, right? 24 atoms. Then molecule, molecule cancel out. And you get this 1.445, 10 to the power 25. You can see all that remains is atoms. So Leah, do you remember this technique of timesing it by factor conversion?
Yeah, I do.
Last week, yeah. So it's a good revision, isn't it?
Yeah.
Now, so let's put that aside a little bit. I'm going to now try the other method of going from there to there. So what does it give you moles of atoms? So I start with 1 mole of molecules times it by this one. So I started with this one first. This time I'm going to times it by that first. So in that case, not entire moles of molecule cancel out here. It was a mole of molecules, mole of molecules. Now it's just a molecule. One molecule gives you 24 atoms, right? So in this case, instead of mole, molecule cancel out, molecules, molecule cancel out. So that gives you 24 mole of atoms. Mole of atoms. That many mole of atoms, that's what you have. And then now we times that by that. Hold on. So we have atoms. Yeah, so in this case, what we get, because it's now in atoms, we have to actually change this to this one. 1 mole instead of a mole of molecules. So you see 1 mole of molecules is that many molecules. 1 mole of atoms, we have to use actually a different mole fraction. I mean, different pair conversion. 1 mole of atoms is a 6.022 times by 10 to the power 23 atoms. So in that case, mole of atom cancel out. So you just get atoms. Yeah, so which is this number here. Yeah, so this is actually quite difficult problem to comprehend at first, but it's something that you definitely must learn before you go to year 11. Now, we're going to move on. We spent too much time there. Okay. Now, we got, yeah, so from now on, it's really easy. I can even give that as homework. So 7, 8, 9. So I'm going to do a few of them and just give them as homework. Okay, so we already dealt with this one. Sodium. Sodium is, if you look at the periodic table, it's right there, Na. Let me copy that, okay? That one there, so it's a bit too small, so I'm going to zoom in. So what is the mass of 1 mole of sodium? Can you guys type in the answer? This is Na, Na is sodium. Okay, anyone got an answer? That's good. I'm not sure where you got the 9, 8 from, but it's actually 9, 9, right? Because it says, I'm not sure if you can read that correctly. Yeah, so the answer is, they're simply asking the molar mass of sodium. So if you have 1 mole of that, That's 22.99 grams per mole. So don't forget this unit. Sulfur and chlorine. That's pretty simple. It's just sulfur and chlorine. It's right here. Okay, so the answer is 32.606 grams per mole. So the molar mass is of sulfur is 32.06 grams per mole, and molar mass of chlorine is 35.45 grams per mole. Okay, so this one is a little bit different, but just need to figure out the mass. Just need to use this formula. Mass is, we know that the number of moles is mass divided by molar mass, right? So mass is equal to number of moles times by molar mass. As for oxygen, this is simply O, not O2. So if you've got, so if you look at B, what's the mass if you have 24.5 moles of oxygen? So that's 24.5, that's number of moles, times by oxygen is 16 grams per mole, right? So you can see that mole and mole cancel out, you get grams. So 1 mole weighs 16 grams, so if you have 24.5, just simply have to multiply by 24. So 16 times by 24.5, that's 392 grams. Now this might be a little bit challenging, so I'm going to do this one here. So calcium, phosphorus, oxygen. So I'm going to say oxygen is 16. Phosphorus, I think, is, let's just double check. Phosphorus 31, about 31. I'm going to type it here. 31. What else did we have? Calcium, was it? Was it calcium or what? Yeah, calcium. Calcium is about 40, I think. So 40, that's right. So phosphorus is 31. Calcium is 40. So what's the molar mass of a Ca3? PO4, 2. That is equal to 40 times by 3, and then plus P is 31, plus 16 times by 3, because it's actually 4 times by 16. And then this one is times by 2. You have 2 of them, okay? So it might be a little bit confusing, but this is 310. So what this is actually like is that you have calcium, but 3 of them. So calcium, calcium, calcium. And you have this big bracket times by 2. So you have this bracket. So that thing there, you've got 2 of them like that. But inside of this bracket is PO4. So I can draw that like P, and then like O. O is like, there are 4 of them. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so I need to make it a bit better actually. It's a bit more like, let's say, let me use different color. So P there, maybe green for P, blue for oxygen, okay? So it's like inside this 2 brackets. So 3 calcium, 2 brackets. You've got that, and that's surrounded by 4 oxygen. 1, 2, 3, 4. 1, 2, 3, 4, okay? So that's what it looks like. So that's why I can get it like this, 40 times by 3 plus 16 times by 8 But oxygen is 16, you know, times by 8 plus 31 times by 2. You get exactly the same. Okay, so that's how you work it out. And then once you figure out that this is grams per mole, that's the molar mass. And this question here says 1.25 mole. So if 1 mole is 310, what's 1.25 mole? 1.25 is going to give you something else. So that's equal to just simply this formula. Mass is equal to number of moles times our molar mass. Exactly. Well done. So 387.5 times by 1.25. Yeah. So 310 times by 1.25 there. Okay. So 387.5. Okay. So you guys can try this as homework, all of this. So I'm going to take a picture of that and send it to you. And also number 9, you can try number 9 as well. So here, number 8 was figure out the mass. Question 7 was what is the molar mass? Number 9 is about what is the number of moles if you have that many grams of the calcium carbonate. So number 9, A. So we've got 21.5 grams of calcium carbonate. Let's figure out the number of moles, molar mass of calcium carbonate. Calcium is 40. Carbon is about, if you look at it, is 12. Okay, 03. So if you add them all up, 40 plus 12 plus 16 times by 3, it's 100. So the molar mass of calcium carbonate, it's made up of 1 calcium, 1 carbonate, 1 carbon, and then 3, sort of like it's attached like this, 1, 2, 3. That's what it looks like. And that's 100 grams if you have a mole. You have 21.5 grams only, so that's much less than 1 mole, right? So number of moles is equal to 21.5 grams. So it's actually mass divided by molar mass. That's equal to 21.5 gram divided by 100 gram. So that is equal to 21.5 is equal to that, which is 0.215 moles. Okay, so I hope that's clear. Okay, so Leo and Mihir, how much of this were you able to follow? You can let me know in a private message if you don't want to share it to everyone. Okay. Mihir? Did you find this one a little bit difficult to follow? I think it'll make a lot more sense. Yeah. Yeah, if you go through the first video, yeah, then you'll understand this much better. Okay, I think we can call it a day here. Okay, so that's the only homework you have to go through. The other one is a little bit more complicated from question 10 onward. We're going to do that maybe next time. But I'm going to give you some homework based on molar mass and stuff like that. Okay. Yeah. All right. I'll see you next week.
Okay.